This lesson is on the mean value theorem for derivatives and Rolle's theorem, which is basically just a special version of that. What the mean value theorem says is, if you are the function you are considering, so you're given some sort of function, and you know that it's continuous and differentiable, so it's basically smooth, on the given interval, so you'll be given an interval, then your average rate of change is going to equal your instantaneous rate of change, or the slope of your secant line is going to equal the slope of your tangent line. And I'm also going to show you this graphically. Okay, so what this means graphically is we have some path, and we're going from A to B on the x-axis. Okay. And what it says is, if I do the slope of the secant line between A and B, there is a point somewhere between A and B where the derivative is going to have that same slope. And so if I'm eyeballing it, it looks like maybe right here would be a place where it would have the same slope. And so I'm going to call that C. So at that point, the derivative has the same slope as the average rate of change, or the slope of the secant line. And it looks like you might have another one over here somewhere. Sometimes you have more than one answer. But it's just places where the slope of the tangent line is going to equal the slope of the secant line. And again, what this theorem says is, if you have a continuous and differentiable graph, in other words, it's smooth, and you're going from A to B, then this is going to happen. Okay, so let's write a few words down to remind us. Okay, our secant line is drawn in here, so what we're considering here is the slope of the secant line. Between A and B. And then the slope of this tangent line somewhere. So the slope of the tangent line at some C between A and B. Those two are going to be equal. They are going in the same direction. They have the same steepness to them. They're parallel. And so that is graphically, again, what that means. And you can probably find multiple other videos on this if you're searching on YouTube and need a refresher from someone other than myself. What it boils down to is the formal writing of what's going on. The slope of your tangent line is your derivative, so we have f prime at that c value, whatever that is equaling the slope of your secant line, which is your slope f of b minus f of a over b minus a. This is algebraically setting those two things equal that we were just talking about graphically, and this is the formula that you really need to know when you're talking about the mean value theorem for derivatives. This is one that we'll be plugging things into and solving today. Okay, so how to work a problem. What they're going to do is give you a function. Here I have f of x is the square root of x minus 2. They're also going to give you an interval. Before you ever start doing anything, you need to realize on that interval from 2 to 6, is this function continuous and is it differentiable? Okay, well, the square root function we know is like half of a parabola turned sideways. This one is moved right too. And so if you're thinking about what that graph looks like, it's something like this. So between 2 and 6, is it smooth and differentiable, continuous? Does it have any jumps, holes, sharp corners? No, this one is good. So we can do the mean value theorem with this function on this particular interval. Now sometimes they'll give you, like if they had said the interval from 0 to 6, we would have to say, well, the function doesn't even exist at 0, so no, we can't do this. It's not differentiable, it's not continuous. So you could only do it if that section of the graph fits those two criteria. Go back to that formal definition. F prime of C equals F of B minus F of A over B minus A. The C is what you're trying to find. You're trying to find the point, the x value, where it's going to equal, the tangent line slope is going to equal this slope. Your A is your 2 and your B is your 6. So I'm looking at this secant line's slope. I'm trying to find the point in there, looks like right here with my sketch. I'm trying to find this C value where that slope of the tangent line is going to match the slope of that secant line. So, let me come back over here. I know B and A, so I'm going to plug those in. So F of 6 minus F of 2 over 6 minus 2. I don't know what C is, but I can take the derivative, F prime. You just remember that x minus 2, when it's under a square root, is to the 1/2 power. So I'm going to say 1/2 x minus 2 to the negative 1/2. Except I'm going to change that to a C because we are supposed to be using C when we're doing this mean value theorem. Then over here I can figure out what these numbers are. F of 6. If I plug in 6, 6 minus 2 is 4, and the square root of 4 is 2. Then F of 2. 2 minus 2 is 0. The square root of 0 is 0. On the bottom, 6 minus 2 is 4. Okay, over here, I have the 1/2 I'm going to write like this, and since this C minus 2 is to the negative 1/2 and I'm trying to solve an equation, when I'm solving an equation it's better to write it as fractions and radicals. So the negative is going to move it to the bottom, the 1/2 is going to say it's under a square root. So I'm just rewriting that in a better way to work with for solving an equation. And so I have, if I simplify that, I have 1 over 2 square root C minus 2 equals 1/2. Well, if I multiply both sides by 2, the 2's are gone. I can cancel those. So I have 1 over the square root of C minus 2 equals 1. And then to get rid of that fraction, I'm going to multiply both sides by the square root of C minus 2, which I could have done in that last step if I wanted to combine some things. So I get 1 equals the square root of C minus 2. If I square both sides to get rid of the square root, I still get 1. And then if I add 2, I get 3. So C is 3. And again, what that means is that is the x value between 2 and 6 where that tangent line slope is going to equal that secant line slope. You definitely want to make sure that the answer you get does fall in between those two numbers that they have given you. Otherwise, something may be wrong with what you've done. But that's the basic idea, is setting that derivative equal to the slope and working it out and finding that value. The next thing that we're talking about in this lesson is Rolle's theorem. And Rolle's theorem is really not any different than the mean value theorem. It just is a special case where the f of b and the f of a are equal. So the slope of your line is going to end up being 0. You still have to have a function that is continuous and differentiable on the given interval. But with Rolle's theorem, the f of b and the f of a are equal. And again, that just means that that slope, that f of b minus f of a over b minus a, that part is going to be 0. Because if you think about it, if f of a and f of b are equal, they're at the same place. And so if I made any sort of graph between them, and I'll just make a really easy one, any sort of graph between them, well, the slope of the secant line between the a and the b is 0 because it would be flat because they're on the same y value, they're on that same level. And all we're doing is trying to find a place between them where the derivative is also 0. So it's just a special case where you have horizontal lines instead of vertical lines. You could work the problem out the same way as you work the mean value theorem out, except, I mean, it's just easier to remember that, okay, that f of b minus f of a over b minus a is going to be 0 when you do Rolle's theorem. So they just simplified the equation to just setting the derivative equal to 0. But you're still finding the same idea there. Okay, how to work a problem. It's going to look really similar to the mean value theorem. You're going to be given some function and you're going to be given some interval. First of all, check to see if the function is differentiable and continuous. And this one is a parabola. So we know that a parabola is nice and smooth, so it's differentiable everywhere, and it is continuous everywhere. It doesn't have any holes or jumps or pointy places. So parabolas are good to work with. Now, what makes it Rolle's theorem is when I do f of 2 and f of 1, I should get the same answer out, whatever that is. So if I do f of 2, 2 squared minus 3 times 2 plus 2, in this case is 0. And then if I plug 1 in, 1 squared minus 3 times 1 plus 2 is also 0. It doesn't matter what that number is, just the fact that they're the same. And that's what makes this Rolle's theorem. So it's just easier now. I can just do f prime of c equal to 0 to find that c, because the slope between those two will be 0. So f prime of c, I'm just going to do my derivative, except where I have x's, I'm going to put c's. So 2c minus 3, set that equal to 0. Add 3 to both sides, and divide by 2. So at 3/2 is where the slope of the tangent line is going to equal the slope of the secant line. And again, we're thinking of a parabola here, and f of 1 and f of 2 are at the same place, and I'm just going to make this up. We'll say that's f of 1 and f of 2. The slope of the line between them is 0. This x value here that has a tangent line slope of 0 would be the 3/2. Okay? So I don't know exactly where that graph is. You'd have to look at your calculator. I'm just taking a stab at explaining what's going on here. Hopefully you understood this. The last thing I want you to remember is the most important thing. You cannot use these unless your function is continuous and differentiable on the interval that they gave you. It doesn't have to be continuous and differentiable everywhere. It just has to be continuous and differentiable on the interval that they give you. Which means that there can be no holes, vertical asymptotes, sharp corners, and things like that on that interval. Okay, so just checking on that interval about that graph, that particular graph. And that concludes this lesson.